being here, and also thanks to our speaker for being here and presenting the program to us. I think we're going to start the way that we always start, and let's introduce ourselves. And let's start with the ladies tonight. Let's start with you.
Emily Gastro with West Star Fire. Melissa Rodriguez with Nimic.
Jim Scheller in Nimic.
Dave Hewitt with Response Fire Protection. Dave Clark with Response Fire Protection.
Adam Graff, Michelle Cooley. Glenn Schaffer, Burns Mac.
Tim Smith, FireNet Systems.
Don Egan, FireNet Systems.
Ed Shaver, FireNet Systems.
And Lee Sloniger, FireNet Systems.
Matthew Drone, not with FireNet. Paul Rivers with 3M.
Paul Watercut, unemployed.
Terry Max with Electric Scientific.
And I'm Ed Meyer with North Fire Design. I believe that there's not much to report other than we're all struggling to keep things going. Scott has a governor's report?
A couple
reports.
I got a couple reports.
Take the whole night.
There's lots going on. As a representative of this group to the Minnesota State Fire Chiefs Code Committee, we met in February and met just after the State Fire Marshal and the State Building Codes Division announced that they weren't going to adopt the 2009 I-codes and that they were going to forego that and look at the 2012s. It was an interesting meeting because that's one of the committees I sat on that's dealing with residential sprinklers, and it was very obvious that the reason they delayed it was not for residential sprinklers, but already BOMA and the National NAHB had already come out with their statement saying that the reason that the I-codes were being delayed was because of the IRC, or the residential sprinkler requirement. A couple of interesting things that came out of that meeting. There's a new insulation out, and I haven't researched this, but if you go to P as in Paul 2 insulation, P as in Paul 2, the number 2, insulation.com, there's a new insulation out that has no thermal transfer apparently, and it's very thin, and you're supposed to be able to wrap CPVC and steel pipe in it, and
Is that going to freeze the sprinkler system? Are you going to be the first to try that out?
No. There's a lot more to be learned about this. It's put in a cold space, but it's something that they've come up with to coincide with CPVC piping, so it might be interesting to look into.
Data?
Yeah, as I said, I haven't read into it. Yeah, they do, and pretty extensive website.
Really?
Yeah.
P2 insulation.
What's it?
P2 insulation.
P2 insulation, right? P as in Paul, the number 2 in insulation, yep. We have been in the process, this code committee has been in the process. This code committee is the one that is made up primarily of Fire Marshals Association, fire chiefs, there's a couple of building officials, there's a couple of public members on it. This is the code committee that actually makes the recommendations for amendments to the state fire code. And they'll make the recommendations to the chiefs, Minnesota State Fire Chiefs, and then they'll decide which ones they want to go forward with as the legislation goes along for amendments to the fire code. So for the last few months, we've actually been comparing the International Fire Code, IFC, with NFPA 1. Some of our neighbors have adopted NFPA 1 instead of the International Fire Code, and we're in the process of comparing the two to see then, since we're not adopting 2009, if in 2012 we might try to adopt NFPA 1 instead of the International Fire Code. And we've been doing those comparisons. We compared 3 chapters, and I personally like NFPA 1 the best, which means nothing. Governor's Council Executive Committee. I'm on the Governor's Council's Executive Board still. We're working on the Governor's Day at the Fair. That's moving along. We need volunteers from this group. There's lots to do. There's 700 volunteers, but we need volunteers from this group. I'm chairing a committee in the Governor's Council that's going to write a white paper. I'm hopeful writing a white paper on the IRC. That would be I hope what we come out with is a very factual white paper that talks about residential sprinklers, the need for them, and we can debunk, if at all possible, the things that are going on from the other side, why we don't want them in. And in those two capacities, the Chiefs Code Committee and the IRC white paper, you can't imagine the amount of information that I get on residential sprinklers. It is just incredible. And what's out there and being done. You all did finish their testing on lightweight construction, and I have not seen it. I've heard that it was very significant that the lightweight construction just doesn't last. It fails somewhere in 7 to 10 minutes. The new homes that are being built with the lightweight construction, the floors are failing before the fire department gets to the scene. And that's why firefighters go through if they're going in, but most fire departments won't go into a building. Maple Grove had a fire a couple of years ago, and the firefighter actually put his foot in the window, and for some reason didn't go forward, and his foot went through. He didn't continue in. I mean, he was stopping, and he went through, and it was a lightweight construction. Anyway, the group that I'm chairing on the IRC white paper is Jeff Shadig with the Fire Marshals Association, Terry Trudeau, Minnesota League of Cities, Bert Tellers, Ram Mutual Insurance, and Jim Fisher, League of Townships. So it's a really broad cross-section. I can assure you that two of those in that group had no desire for residential sprinklers even in new homes until they sat in and we started getting all this information. And they actually went to the NFSA forum yesterday, the residential sprinkler forum that NFSA put on, and they came out of that thing just glowing with unbelievable amount of information that was available. So if you get a chance or want to do more on the IRC coalition that I sat on is looking for volunteers. And we are not in so much of a hurry now that the 2009 won't be adopted, but we are in a hurry because we have decided that the number one thing that we have to do is education. And education has to be to fire departments, and it has to be to the public, and it has to be to the building officials, and then we can get the right information to those people and they can spread it out. And so we're making presentations, PowerPoint presentations that should be done in April, and then those presentations will be available to volunteers who want to go talk to groups. And I talked to the Southern Minnesota building officials 2 or 3 weeks ago, and it's just a great meeting because those are individuals that are not pro-sprinkler, and in many cases they're against the sprinklers, and they think that the IRC means you got to put them in all existing homes. No, new homes only. They think that you got to have huge water supply. No. They think you can't do it on a well. And it's going to cost them $10 a square foot. So on the other hand, for those sprinkler contractors that are in here, we did hear the other day again of another metro area where individuals trying to get residential sprinklers in their home and cannot get a bid. So we need to educate contractors too, and somehow we got to bring this together so that somebody's going to be actually out there putting them in when people are looking for them. And finally, today was the Governor's Council on Fire Prevention meeting. We had a really outstanding presentation by Dr. Robert Schroeder, a member of this group, on some of the fire testing that he's done relative to ag barns, agricultural buildings that are not governed by the building code. And he's been involved with investigation of several large fires in the multi-million dollars, hog barns, turkey barns, things like that. And the common theme, or the common construction material in those is FRP, or the fiberglass reinforced plastic panels. And he mocked up and made a few tests that show how quickly the FRP, which has a pretty decent flame spread rating in the Steiner tunnel test, horizontal, but when you put it in the vertical where it's actually installed, it burns really well, and or really good, or something like that. Anyway, a good presentation. The just thrust of that was to get the Governor's Council behind trying to get the ag buildings brought back into the building code so that they have some design guidelines. And then we had a presentation by Novartis for a new program that they've got, which is called Stop, Drop, and Control Blood Pressure. And it's aimed initially at the firefighters. I think they said today something like 2 in 10 people have high blood pressure, but 5 in 10 firefighters do. And so they're going to try the Stop, Drop, and Control campaign for firefighters, but then they want to bring it to the public. And we're hopeful that we'll have it at the Governor's Fire Prevention Day at the fair, and they'll have a booth there to educate people and take blood pressure and things like that. So that's, I think, what's going on, besides the IRC Coalition, which I talked about. We need volunteers, so we need volunteers for all this stuff. Doesn't mean you have to attend a bunch of meetings, but if you're looking to get involved, whether it's a residential sprinkler issue or others, then let me know.
Thank you very much, always much appreciated. Well, let's get started with our program. We'll be patiently waiting. And flexing the muscles in the laptop there and make sure that everything's working. Do you actually call yourself Jonathan or John?
Yeah, Jonathan's right.
Jonathan Ingram, okay, from Fenwell Fire Protection Systems, got the floor. Go for it.
Okay. Like I said, my name is Jonathan Ingram. I'm with Fenwell Fire Protection, or Fenwell Protection Systems. I've been in the industry for about 13 years. Started off as graduated school with electrical engineering degree, and quickly came into the fire protection industry as a applications and electrical engineer, and then moved from engineering to product specialist for detection and control with cross-training and suppression, and then moved from there to product management of detection and control and suppression, and then moved out of the factory as a regional sales manager, and did that for about 9 years, and now I've just started as the national sales manager, overseeing the whole Fenwell business just as of January. So, but one of the things that was identified that you guys wanted to have covered was kind of an overview of what's available today, and as far as fire protection and protection of mission-critical facilities. I know you guys are probably a little bit heavier sprinkler concentration. I know Minneapolis and the surrounding area is really pro sprinkler when it comes to across the board. And by no means is my presentation trying to at all discredit sprinklers or say that they don't have their place. It's more or less saying that there is a place for everything, and actually using both in conjunction with each other is probably going to be the best form of fire protection when protecting these mission-critical type facilities. So I figure I'd get that out of the way right now before I offend anybody, or if I did, you can take me out back and we'll settle our differences. So really what I want to do is I want to talk about mission-critical facilities, a review, talk about fire protection strategies, look at risk and total cost of ownership, look at waterless fire protection systems, current waterless options that are out there. Then we'll go over as an overview on detection options, and then kind of sum it up with system solutions, and we can have a further discussion after that. By any means, if you guys get questions, I know sometimes when we all think of the questions that we want to ask, a lot of times people will say, we'll hold them to the end. Just ask them, raise your hand. I'll be more than happy to take some time and answer that as they come up. So everybody pretty much know what a mission-critical facility is. It's a activity, processing, application, or facility which is deemed vital to the organization's business success or possibly its existence. Right now, if you look at healthcare, if you look at data collection, if you look at even in the engineering firms and various other places, everything is now on IT. And even in the engineering firms, you still have old drawings that were pre-IT that haven't been scanned in or something else. So, if a company or an engineering firm lost all of their data, what would happen? Basically, they wouldn't know, we would have to start from scratch, but it could mean that they may not be able to exist. Same thing with everything's online now. How many people shop online? You guys? Well, my wife does, so, sorry. But, shopping online, it's kind of a common thing now. We get upset when the websites are down, or we can't get our order through, or something like that. I don't know if anybody talked or heard about the fire that they had up in Green Bay, where they had a web hosting company that was hosting corporate email, corporate websites, and everything else. Didn't have any fire protection. Okay? Had a fire, shut down 3 city blocks for the fire. Cost them somewhere around $3 million in equipment damage. And it took them, I think it was 3 weeks to get back up online. But by then, I mean, I had distributors, I had companies that were hosting their websites and their vital communications paths to the customer, to them, were down. What they do? They jump ship and they went to someone else. So, it's not only how fast you can get back up and running, it's what's going to happen as the collateral damage, because that site is now down and you're losing business on a minute-by-minute basis. So really what we're talking about with suppression strategies is we're going to look at facility recognition and analysis, where we're going to look at value of assets, both monetary and operational, what the potential, you got to look at it from a potential downtime aspect, and then you have to look at what the replacement costs are. You may be able to replace certain things, but it's how long is it going to take and at what price. And I know from my friends that work in the IT industry, even when they go and they do a upgrade on the computer system on the weekends, that they're supposed to take 2 hours, usually take 2 days. So nothing ever works right in bringing that up. Really also what you want to look at is the current protection strategy that's employed. When looking at clean agent systems or waterless fire protection, you really need to look at the integrity of the space, if it can be sealed to be able to hold the retention of the gas in that space for a certain period of time. Right now, NFPA 2001 says gaseous agents shall hold for 10 minutes, but the authority out of jurisdiction has the authority to reduce that time or increase that time as they see fit. I've seen authorities having jurisdiction go out there and they'll go down in rush hour and go to the closest fire station to the site that they're going to sign off on, and what they'll do is they'll drive it. And however long it takes them to get to that site is what the time's going to be. So, it really depends there. Anytime we're putting any system in, we always have to check with regulatory and insurance influences. FM might want one thing, the authority having jurisdiction might want another. We're going to look at also the total cost of ownership and then overall risk within the facility. So this is a matrix that a lot of the risk analysts look at when assessing a certain area. So they're looking at probability versus impact. So really, when we're looking at waterless or mission-critical type facilities, we're looking at facilities that are either shaded in the red or in the orange that may pose a probability that something might not happen, but if it does, it's going to definitely impact the business in a serious or critical nature. Or you might have something that has a high probability of happening, and it may have a critical or minor type effect on the company itself. So when we're looking at total cost of ownership, we're looking at how much is it going to cost to initially install the suppression and electrical equipment, and how much the equipment itself is going to cost. But then also you have to look at the total cost of maintenance, service, productivity, and even some of the real estate that gets taken up. So some of the total costs associated with system activation could be detrimental depending upon what system you choose as your method of fire protection, or if you choose fire protection at all. So you may have some customers that don't have any protection. You may have some customers that say we're going to put in detection only, spot type detectors, air sampling, or something else. Then you have some customers that will just put in what's required by the International Building Code or the local building ordinances just to get occupancy. and that could be just putting in water-based systems, either wet or pre-action. But then, some companies, and most companies that have mission-critical facilities are looking at putting in waterless systems or a clean agent. Now, what we're saying, this kind of goes back to what I said at the beginning, where waterless and water-based systems can work together, where your waterless system or your clean agent system could be your primary form of defense in stopping the, or actually putting out a fire and getting the customer back up and running in a timely fashion. But then if something does happen where you're looking that the fire grows to a point that it's catastrophic, you want to look at it from have a pre-action or a wet system as a backup. And preferably, if we're going to be using sprinkler systems, you want to put a pre-action system in there just to keep the water, because everybody's always afraid of a leaking pipe or something else happening in their data room. So I have a quick, now I didn't bring my speakers, so I hope you guys can hear this, but this is some of you may have seen this. I'm only going to show the first few minutes, but it just shows the difference between having a water-based only versus a clean agent as a primary output.
What's the thing about it, but the risks are all too real. What would happen to your critical business systems and irreplaceable assets should a fire break out? We decided to find out. Suppose that this office contains your company's most critical equipment, information, technology, data, records, and files. You think you've taken reasonable precautions. You've met all local building codes. Like most companies, you've installed an automatic sprinkler system designed to release water only after a flame has grown into a substantial fire. Water provides a minimum level of protection for your essential equipment, systems, software, and the irreplaceable information your business depends on to survive and grow. But is minimum protection ever good enough? After hours, suppose an electrical malfunction inside an equipment cabinet causes a spark to ignite. 1 minute and 51 seconds, the system's detector senses smoke, sets off an alarm, and charges the pipes with water. As the fire continues to grow, the temperature of the ceiling directly above it will climb slowly until it is more than 500 degrees. The equipment inside the enclosure is now completely destroyed. Still, the temperature at the nearest sprinkler head stays below what's necessary to initiate the release of water. 9 minutes and 46 seconds, the sprinkler ball bursts. Water is released at a flow rate of more than 18 gallons per minute. The room fills with smoke until there is no visibility. The infrared camera detects the flames contained and shielded inside the metal cabinet. 17 minutes, a firefighter arrives to investigate and finally puts the fire out. The automatic sprinkler system in this office worked exactly as it was designed. After the fire grew large enough, it provided the minimum protection necessary to slow the fire's growth until the firefighters arrived to put it out. But the result of this minimum level of protection was an unacceptable level of damage to your business. Chances are it would have saved your building and the lives of your employees. But would it have saved your business? Suppose instead you had an FM200 waterless system.
Now this could be applied to any waterless fire suppression system.
Suppose again it was after hours and an electrical malfunction inside an equipment cabinet causes a spark to ignite. 32 seconds. The system's detector senses the first whiff of combustion. 1 minute and 3 seconds. A first alarm is sounded. 1 minute and 35 seconds. The system sounds a second alarm and begins a 30-second pre-discharge countdown. 2 minutes, 5 seconds. FM200 is released. 10 seconds later, the fire is out. An FM200 system provides maximum protection, resulting in minimum damage. after some final.
Okay. So that just kind of shows you the difference between a waterless system versus a water-based. And the only reason that the water-based system wouldn't have, or didn't work in that particular scenario was because the cabinets formed a shield. So it wouldn't have penetrated the cabinets, where a gaseous agent, as it circulates through the whole entire room, gets into the every nook, cranny, opening, or whatever to put out that fire. So, like I said, we always suggest to any end user that we do business with, or that they ask our opinion, gaseous agents should be a primary form of putting the fire out, with being always backed up by a pre-action sprinkler, because really the sprinkler system is basically for structure and life safety, for structural integrity, where the waterless system is more concerned about the assets. So just some applications where we use waterless fire protection, clean agent systems, data processing, telecommunications, power gen, marine, industrial applications, healthcare. We use a lot of stuff in the MRI facilities, record storage, especially with HIPAA. HIPAA in the healthcare industry is probably the biggest thing. Every time you go to the doctors, they make you sign the form, or they don't divulge your information to anybody else other than you. Well, they also have a responsibility of keeping your records secure for 7 years, and that means from a fire protection aspect and from a security aspect. So also the healthcare facilities are getting more IT-based. There's a big movement within the healthcare facilities to make your experience from the time that someone picks you up in the ambulance to the time you get to the hospital as being completely over the computerized. So they'll be able to zap your EKG and various other types of things right to the hospital before you get there. They'll be able to assess what you need and then be able to roll the appropriate equipment in before you even get there and assign a room. And then also be able to use the data processing for in-home care. So if a physician or an in-home nurse comes in, and they can look up that patient's records, see what their prescriptions are, whatever else they need to be taking. So healthcare is becoming very much IT, and I don't know if you've been paying attention to the news, but I know that the new administration is concentrating heavily on infusing money into the healthcare system, for upgrades and various other things, not only just providing healthcare to everybody.
Were you guys actually involved in looking at the flag there?
Yes.
Restoration?
Yes.
I was in Washington last week in a committee, and one of the guys actually was involved in fire protection in that building. And he was saying that the final display case, one of the main concerns was that any kind of pressure, air movement, even from gases, was an issue.
Mm-hmm.
How was it actually resolved? Because he didn't actually not give me the final hoedown.
I believe what they did was they created a special nozzle design that reduced the amount of pressure that was than what a standard FM200 design would be.
So we would fill in the display case, but not directly on the
Yeah,
flag area.
they also, I believe in the flag area, they're also protecting it with an inert gas as far from a preservation standpoint.
I think he also said that they also lowered the oxygen content of the air in the case.
Yes.
So they evacuate the oxygen out.
Yes, yeah, because it also helps preserve the actual flag from deteriorating over
There's
time.
reduced oxygen and there is a gas system
Yeah,
in the display case, which is just a separate issue altogether.
yes. But the main system that you see here, or I should say see here, was back in the restoration area. So that whole area was actually being protected.
And it's a much bigger space than the display case.
Yes, oh yes,
Yeah,
definitely.
exactly.
Definitely. One other story to tell you about healthcare is that there was a fire, or I should say an event, that happened with an MRI unit, where the board that moves the bed in and out of the MRI actually shorted out and started a fire. Well, they couldn't get the guy out, but they had a gaseous system in there. It put the fire out. The one thing about gaseous systems that some people are is a big misnomer, is that it takes the oxygen out of the atmosphere. There are gaseous systems that do that when you're dealing with inerts, nitrogen, argon, CO2, various other types. But when you're talking about clean agent gases like Novec 1230, FM 200, or any of the others, those don't those extinguish by cooling rather than by oxygen deprivation. So
is it still 5% concentration or is it a little more?
different agents have different concentrations, and we'll kind of go through that as we kind of progress here. So the first clean agent, or first true clean agent out there, as far as suppression, was halon. It was fast-acting, minimal damage, safe for occupied spaces, but it had an ozone depletion potential. And it was basically taken out via the Montreal Protocol back in 1988, and then it was finally phased out from production. I think it was around 1991, 92. So halon's still available, but it's only available in the recycled state. So, but also from a halon standpoint, especially for the guys that are more in the consulting or telling customers what to do with their existing halon systems, a lot of the manufacturers have stopped supporting the old halon systems. So any kind of rebuild kits, or if they should have a discharge, there may be halon available that they can source, but they may not be able to rebuild the valves and put the appropriate O-rings in there to be able to bring that system back up and running. So halon is no longer available in brand new systems unless you're getting a used type system. Now, everything that I'm going to talk to you about in the next few slides are governed by NFPA 2001, and I believe I was talking to Paul, and he said that he kind of gave you guys, in a previous presentation, that kind of gave you a little bit of a synopsis on NFPA 2001, which is the standard on clean agent systems. It covers the safety, components, design, test, inspection, and maintenance of these type of systems. So today's commonly used clean agent options is FM 200, Novec 1230, Argonite, FE25, and Ingram. Those are probably the most widely used that you'll see here locally and nationally throughout the U.S. Now, when talking about clean agents, one of the things that we want to just kind of cover is some different terminology that I'll be having on a few of the slides. One is NOAL, which is no observed adverse effects level. That means that during testing, when they did testing on the agents back in, say, 1992, when the halon was being discontinued and they were searching for replacements, they basically tested it to a level that they didn't see cardiac sensitization. And that is what they established as NOAL, so no observed adverse effects level on the test subjects. Now, there's a low AL level, which stands for lowest observed adverse effects level, which means that they saw a blip. It could have been 1 out of 10, it could have been 1 out of 100, it could have been 1 out of 10,000 tests. But what they did was they established the minute they saw a blip, that's what they said was the highest or the lowest concentration that they actually saw an adverse effect. Then something new came out called the PBPK, the Physiologically Based Pharmacokinetic Model. You guys say that 10 times? So what this is, it's a computer simulated test. It's kind of like saying, okay, if what this test does is it tries to relate what the concentration will be at your heart at a given time for a given exposure period. So is that pretty much that? Okay. But really what this is, it's more of a, it's a computer generated model. But it basically is trying to say, you know, if you have different subjects, trying to relate different subjects, if someone has a drink that doesn't drink all the time versus someone that has a drink every day, the effects are going to be different. But the computer model may say an average person weighing 120 pounds or 200 pounds, is going to have this effect if they have 2 drinks in an hour. So that's really what it's doing. Typically, with all the chemical agents, you're going to deal with fluorines, carbons, and oxygen, and hydrogens. With inert gases, you're going to have some sort of either virgin blend or mixture of argon, nitrogen, and CO2. And then we'll also talk about design concentrations, which we talk about Class A, Class B, and Class C. Class A being your combustible plastics, woods, papers. Class C being your energized fire, computers with electricity to them, the projector here with that's in the on position will be a Class C, but if I unplug it, it becomes Class A. And then Class B fires are your flammable liquids. Basically, we're protecting with Class Bs, we're protecting flammable liquid surface fires. So some alcohol fires, methanol, diesel fuel, some other flammable liquids. So talk a little bit about FM200. FM200's probably been the agent that's been out there one of the longest times. HFC 2270A is its ASHRAE designation. It's also called heptafluoropropane. It's safe for occupied spaces. It does suppress through heat absorption. There is the definition of a clean agent is that it does not leave a residue, does not conduct, will not wet or soak, and there's no agent-related downtime. Typically, with these type of with the FM200 agent, the design concentration will be from 6.25% for a Class A fire. In a Class C fire, the general guideline is to have a 7% design concentration. The no observed adverse effects level is 9%. The low AL level, lowest observed adverse effects level, is 10.5%. So you have anywhere from the no AL level back down to the Class A level of about 2 3/4% safety factor, and here you have about 2% safety factor before you get to the no AL, and then even a 3.5% safety factor of low AL. It does have zero ozone depletion potential. It does have a lower atmospheric lifetime, and when I say that, it's lower than halon. Halon had an atmospheric lifetime of, I believe, about 80 years, 80 or 90 years. FM200 has an atmospheric lifetime of about 33. So it's still quite a bit. Now, one thing that FM200 has been used in is meter-dosed inhalers as a replacement propellant. So it was tested by the FDA in medical inhalers. Now, because FM200 has been on the marketplace for a long time, I'm going to talk a little bit about, there's some traditional delivery systems, and then there's some application-specific delivery systems that you may want to be aware of. Traditional delivery systems are top discharge cylinders, and I got pictures on the next slide. Bottom discharge, spheres, and bottom discharge can be referred to as burst-dis technology. And then we have application specifics. So here is your top outlet cylinder. These would be your bottom discharge cylinders, hence they discharge from the bottom and have a burst disc in here. And the spherical containers have a burst disc, which are either actuated by gas-actuated cartridges or initiators. The top outlet cylinder are mostly actuated by solenoids. Then you have agents or application-specific delivery, where you have complex and pipe networks that may be a Halon 1301 retrofit, large open area facilities, remote cylinder storage locations, where you may have a cylinder filled with FM200, and then you'll have a propellant, the nitrogen propellant, separate, which allows the agent to actually be pushed a lot farther than a standard system. When you have a standard system, the system may be filled to X% of the total fill or the total capacity of the tank, which only leaves a certain amount of head space for nitrogen to be introduced, which then is pressurized, or the cylinder is pressurized at 360 psi. The minute the cylinder opens up on a standard system, so forget this is here, on a standard system, the pressure curve automatically degrades down to zero. So you may only be able to push with a standard suppression system 50 to 60 feet of linear pipe. With this type of system here, you may be able to push the agent 300 to 400 to 500 feet. So it's definitely something to be aware of as far as when you're doing Halon retrofits, because it allows us to use some of the similar, or allows it to use some of the similar piping that was used in the 1301. Although I will say this, there is no immediate drop-in replacement available for Halon 1301. Okay? The reason is because I guarantee you, if you tested Halon 1301 to the standards that UL and FM and some of the testing agencies put the agents through today as far as flow splits and discharge time and arrival time balances and various other types of things, the Halon systems, when you have those spaghetti systems, probably wouldn't work to today's standards. The only reason why Halon systems worked back then was we were afforded the discharge test. And the discharge test would allow us to find out what the concentration was in a certain area, and if we needed to bump up concentrations in other areas, we could make modifications, put a little extra Halon in the tanks and recharge, and then retest. With some application-specific design criteria with this particular array, you do have some selector valve capabilities and also the capability of doing difficult design systems. So really how this is working, how this would work is that you have gas and nitrogen in two separate systems. The nitrogen starts to discharge from the nitrogen cylinder into the FM200 cylinder itself, and then pushes it out. It's more like a piston effect.
So what used to be a problem with the Halon was that the cylinders were pre-charged.
Right.
Which then became very hazardous to transport. That was a big problem. So if you're supplying separate nitrogen bottles instead of make the actual storage tank, which is now no longer pressurized, easier to ship.
The DOT actually qualifies hazardous goods for transport as anything over, I think it's like 7 or 8 PSI, normal vapor pressure. It's somewhere in that realm.
So it still exceeds
It's still, yeah, the normal vapor pressure of an FM200 gas is about 44 PSI.
Oh, so you still have that residual problem.
Yeah.
Okay.
So, but, so you still have that it's still stored or transported as a hazardous good. But this kind of just shows the difference, as I was talking about before, when you open up a standard system, the pressure automatically degrades. Now, we still have to make a 10-second discharge time. With the other system that I showed, you basically are maintaining your nitrogen pressure for a longer period of time, but still maintaining your 10-second discharge time from delivery. You also have application-specific systems with in-cabinet. Maybe a customer end user doesn't want to necessarily look at the whole entire area that he wants to protect, but maybe he has a specific piece of equipment that he wants to protect. You may see some of these in-cabinet systems on CNC machines. You may see them on things like storage tech silos, various other types of things, or some hybrid. So really the strengths, you got cylinder storage space, rapid discharge and extinguishment property, people safe, availability, field recharge, support, and application-specific delivery. Weaknesses or recharge cost, and if you're using a traditional system, will be traditional system constraints. So the next agent that's available in the marketplace today is 3M's Novak 1230 fire protection fluid, which I'm not sure how much you have had experience with it, but its actually designation is FK5-1-12. It suppresses also through heat absorption, so it does not deplete the oxygen level. Safe for occupied spaces, no residue, not electrically conductive, will not wear soak, and no agent-related downtime. It's a liquid at room temperature. How many people have seen Novak? Okay. I'm sure Paul here, everybody's seen it. But, basically it is a liquid at room temperature, but it wants to evaporate 50 times faster than water. So I can actually just pour some off here, and I can actually, I know you guys can't see this, but I can see a vapor trail.
Put it in front of the,
In front of the projector.
just pour it on your laptop.
You see that?
Yeah.
You just-
Move it closer to the screen.
I always try that, it never works. There it is. So, anyways. So it wants to gasify, so the way, even though it exists as a liquid at room temperature, when it actually gets delivered through the nozzles actually atomize it into smaller molecules that allow the normal energy in the atmosphere to flash into a gas. And it does not, it's not like humidity where if you lower the temperature, it's gonna, drop down or condense over a period of time. Now for Class A and Class C fires, this agent's rated for 4.2% by volume. So you still have 95.8% air, normal air, in that room. Its no AL is 10%, its low AL is greater than 10%. All this means is we really haven't established there hasn't been an upper level established yet, because typically, I think the largest or the highest concentration that I've seen for some of the most flammable liquids in Class B fires, and that's really where your concentration levels will go up. I think the highest one I've seen is somewhere around 9%. So I think it's around 8.44. Now the big advantage of Novak 1230 is it's not only at zero ozone depletion potential, which has to be met by after the Montreal Protocol is signed, but it's got a 5-day atmospheric lifetime. So anything that's discharged into the atmosphere will break down in a normal stratospheric ozone under sunlight. So if I took a bottle of Novak 1230, put it outside in a clear container, open the cap up, in a couple hours or maybe even a day, it'd be gone. The other thing is that the global warming potential is 1. And I know that there's a lot of debate today about greenhouse gases and various other things and contributing to global warming, but this has the GWP of 1. Now comparing it to an FM200, FM200 has a GWP of around 3,400. So it's significantly better as far as it from an environmental aspect. Now from a delivery system, this is a relatively newer product. It's been on the market since 2003, but really traditional delivery systems prevail in its application. Not to say that something similar to what we saw with FM200, as far as those delivery systems won't come out, but at this point, you're really dealing with a pressurized cylinder at 360 psi with the agent in it. Hardware is similar to, the hardware being used is the same hardware similar to Halon and FM200. So, one good thing about Novak is it's demonstrable. I'm sure you guys have probably seen this for the 5th time, 6th time, 7th time. But I can just put a little drop in here. Shake it out. Nothing in there? Nothing on the sleeve? Nothing on there. What I can do so actually what you can see here is the smoke floating on top of the agent. That would actually represent your protected level. You see it? So that would represent your protected level, and anything underneath that protected level would actually be continuously suppressed. So if you had a 911 center or a data center or something else that they didn't want to shut down, that would continuously suppress that fire as long as the concentration was still in that room at that level. So the strengths of Novak is its environmental characteristics, people and equipment safety, rapid discharge. Again, it's going to discharge in 10 seconds. Now this is where this kind of differs from FM200 and Halon, is the ease of agent transportation. And this kind of goes back to your question, where if we ship Novak in its raw form, because it has a very low vapor pressure, it doesn't come under the DOT guidelines, so they could put thousands and thousands of pounds of the agent on a plane and ship it overseas, or ship it across the US and have it there the next day, or have it there in hours, because it's not under the DOT regulation as far as being able to fly. Where once you get over 350 pounds of like an FM200 gas, you have to truck it. So this is definitely a benefit when we're talking about that. There is some system design flexibility, and it will vary by OEM, because Novec is just the agent. It depends on the performance of the system of the manufacturer that designs that particular system. Another key part about Novec is that it offers the blue sky warranty. What this is more or less a backing. We hear about the stuff about global warming potential, and we hear about the stuff about agents maybe have gone away, are going away, or something else. What the blue sky warranty is saying is that if for any reason when you install your system, if in 20 years that system becomes mandated to be taken out, kind of like Halon was, or not taken out, but if you're required, or legislation is requiring its removal, that 3M will actually pay $18 a pound, I think it is, or I think that's what the going rate is in the blue sky warranty. So they're kind of backing it up as far as the environmental characteristics of this agent and how it's going to benefit going forward. Now, some of the weaknesses, agent quantity required, and the agent cost. So, and cost is actually going to be, no matter if it's Novec, FM200, or any of the other gases out there, cost is always going to be a factor because, it's not free. So, okay, next one, FE25, known as HFC 125 or pentafluoroethane. It suppresses heat absorption. Its history is that it appeared in the early versions of the SNAP list. Back in 1992, when the agents were going through their testing, same time FM200 and some of the other ones were going through, the testing showed that it was not viable for occupied spaces. The reason why is that its design concentration was actually above its NOAL level. So they did not allow it as part of the SNAP list and to be used in occupied spaces. DuPont elected to endorse FE13 for occupied spaces, but FE25 was successfully used in non-occupied applications and also in industrial explosion protection applications, because a lot of those areas were not occupied. Bag houses, grain elevators, various other types of things. So in 1999, the PBPK model came out and basically allowed a more liberal interpretation of toxicology and egress restrictions. So it allowed FE25 to become commercially viable for occupied spaces based upon the PBPK model itself.
And why would you specifically select this versus FM200, or why are you making that choice? Price?
Yes. Actually, the strengths of FE25 is that A, it requires less agent than some of the other agents out there, but B, it's aggressively priced, on a per pound basis. So that's really what if people are looking solely on price, this is the agent that they kind of migrate to on the upfront. Some of the weaknesses of the agent is it's marketed as the cheapest alternative. There is some concerns about the toxicology history, because the PBPK, although it is a computer simulated model, there hasn't been any future testing since back in '92 on that. Its design concentration is above the NOAL. The NOAL for the agent is 7.5%. Its low AL is 10%. Its minimum design concentration for a Class A fire is 8%, and anywhere between 8 and 8.5. there was only one single supplier offering FE25 through its supply chain. And also that there is some, one of the things, and I say halon retrofit capability overstated, it kind of goes back to what I said before. There is no halon drop-in replacement. The one thing that this statement was being made off of was that the FE25 does have a similar vapor pressure to halon. Okay, therefore, by thought, you would think that it would flow the same, but it doesn't. So, you know, it's not exactly, and again, I state, it's not just this agent, it could be FM200, it could be Novak, it could be anything else. It's not a halon drop-in replacement agent itself. Argonite. Now we're getting into the first class of agents that we talked about were the chemical agents, which didn't deplete oxygen levels, but they did cool the fire to put it out. Now we're going to talk about inert gases. And the inert gases, the way they extinguish the fire is actually by taking the oxygen level down from 21% down to about 12.9, 13%. So this is a slew of bottles for an argonite system that was protecting a refinery, and I think the space was about 4,000 square feet. So with 12-foot ceilings. So this is actually what you would need to protect that area. I think there's some selector valves in here too. So
There's a stair bank there.
what's that?
There's a stair bank.
Yes. But the one thing about, you know, inert gas systems is that, you know, just like with any gaseous system, you have to take out all the hoses every 5 years, have them hydrostatically tested. And then after you have a discharge, these have to be hydrostatically tested per the DOT regs. So, and even after a discharge, you have to pull all these tanks out, bring them to a refiller, and have them refilled. So, argonite is actually a 50-50 blend of argon and nitrogen. It's readily available. It can be filled by any gas supplier, whether it's a welding house or someone like an Airgas or Air Liquide or any of those guys, ATA. It's safe for occupied spaces. Its concentration is, for Class A, is 37.9% by volume. So we talked about no AL and low AL. So the low AL level is a little bit different for inert gases because they go on oxygen levels versus going on percent concentration by volume. So the low AL for the argonite system is 12% O2. Asphyxiation happens at about, below 10% O2. So that's where you have to be a little bit careful when designing inert gas systems, because if you put 1 or 2 bottles too many, it could be, especially in a small area, you could take this level of being safe to now being hazardous to the occupants. Also with these type of systems, you have to be a little bit more, do a little bit more due diligence. If you have a regular chemical system, an FM200, or those types, if someone takes a wall and they move it in 3 feet, it may not affect the overall concentration to the point that it starts to get hazardous to the occupants. But if you move a wall 3 feet here and you change a couple other things, it changes the whole perspective of how that system works and what the oxygen levels may be. So it's more important when a customer makes changes to the areas that where inert gas system is installed, that they need to let the installing contractors know that those changes have been made so that they can re-verify the calculations.
So how is that for vapor pressure inside the containment area?
I mean, as far as the pressurization of the room?
Yeah, after discharging the gas, is there more pressure?
Yeah, well, there's more pressure because you're forcing in a higher concentration by volume
I would think so.
of gas.
So
that's
the
what.
leakage is a bigger issue?
Yeah, well, you need more leakage, and actually you need to create man-made leakage on these type of systems.
Otherwise you don't get the stuff in there.
Well, no, you get it in there, but the air that it's replacing is going to look for a place to go.
Well, that's what I meant, yeah.
Yeah.
Gotta push it out.
It will push it out. So if, we always say with these type of systems, if you don't vent the room will be vented, at the end. And
What comes out is.
yeah. And the one thing about venting is that, there's a calculation that's in each when a manufacturer does calculations for these type of systems, or installer does these, typically the software that they're using will calculate the area required based upon the volume of leakage. And then they have to take that and compare to what the normal leakage of the room is from the door fan test, and then put the appropriate pressure relief vent in. And sometimes it's, there's different schools of thought. One is, they'll have a vent that will open up for the first 10 seconds of discharge and then shut. They'll have another one which is more barometrically controlled, where once the pressure gets to a certain level in the room, it will open up, and then as it equalizes, it will shut down. So, but the benefit or the features of this particular agent is it's zero depletion potential, zero atmospheric lifetime. Density of the mixture is more similar to air, so if you have areas that can't necessarily be closed off or sealed, required for that would be for tightness, as we would with some of the other agents, this may be a better solution. It's electrically non-conductive, but it does suppress the agent or suppress the fire through O2 reduction. It's environmentally friendly, cost-effective to refill on a per-pound basis, but it's very labor-intensive to pull all those cylinders out and have them refill. Does not require airtight enclosures. You can use selector valves with this, and you can recharge by any gas supply depot for that. Some of the weaknesses: it's costly and complex. It's a costly system because you're dealing with high pressure. Typically on an FM200 Novak FE25 system, you're dealing with Schedule 40 pipe. With an inert gas system, you're dealing with typically Schedule 80, Schedule 160, at least on the manifold up until the pressure reducer, and then you're reducing it down to Schedule 40 pipe. So there is some significant cost because you're dealing with high pressure cylinders also. You do need significant storage space for the cylinders. Typically a 27,000 cubic foot room, you would need, with FM200 Novak FE25, you probably need somewhere around 1 or 2 cylinders. With an argonite system or inert gas system, you could be talking anywhere between 27 to 45 cylinders, depending upon what gas you choose. So, and each cylinder takes up a 1x1 space. That could be a major concern, and that's why I think in the U.S., inert gas systems probably make up about 5% of the total applications for clean agent fire suppression, where the chemical agents make up about 95% of the applications. Now, if you go to Europe, it's different. They're all about inert gases, and they're very little about the chemical gases. There are some safety issues with handling and storing high-pressure cylinders. And again, going back to what I talked about before, you need a precision volume calculation based upon to make sure you're prescribing the right system design. Now, Energen. Now, the only reason I'm talking about this is because it's a different inert gas. It's a different inert gas that has a different blend. And really what you're talking about is a blend of nitrogen, argon, and CO2. 52%, 40, and 8%. That is a precise blend that has to be met. The CO2 is really in there, or it's being stated that the CO2 produces an increased breathing rate in an oxygen-deprived environment. But it also happens that a 3-component mixture equals a proprietary mix. So, if you mix 2 components, it doesn't necessarily become proprietary. Suppression through O2 reduction, similar characteristics to the argonite design. Now, some of the strengths is its environmental profile, product maturity, particularly in Europe. And they do offer something called the Evergreen warranty, which basically says if you have a fire, they'll replace your gas at nothing, but you still have to pay for the labor charges of taking out all those cylinders, transporting them, and then having a customer down for a certain period of time. Now, as far as weaknesses go, hardware intensive, high pressure discharge, pressure venting required, realistic recharge availability, because it's a three gas blend with the CO2, it creates difficulty in recharge. It must be filled and certified by an authorized gas blender. So, and the blender has to sign off that has been filled to those particular requirements. Because if you put too much CO2 in it, you can cause the O2 level to go down. But typically, whether it's an Energen or Argonite or anything else, you're going to have definite increased costs in large systems. Typically, if you compared a chemical-based system versus an inert gas-based system, you're probably looking at about a 20% price differential because of the high-pressure hardware and the high-pressure piping that's required. Again, chemical agents require Schedule 40, Class 300 fittings. Inert gases require Schedule 80 or Schedule 160, Class 3000 fittings. So that's it pretty much on the suppression side. Any questions? If I lulled you to sleep? Anybody awake? We're just going to talk a little bit about detection options that are out there for mission-critical facilities. Really, we're going to talk about the first two spot-type smoke detectors, air sampling. There are also beam and video, but in mission-critical facilities, when you're looking at protecting or releasing a suppression system, you don't necessarily always want to use these. Beams are great for atriums and large open spaces, but not necessarily in a gaseous or mission-critical facility. And video smoke detection is on the rise, but it hasn't necessarily been honed to the point that it would be as reliable as one of these first two. So as far as detector spacing, all detector spacing for the detectors are per NFPA 72. It used to be Chapter 5, but I know they kind of swapped things around in the last revision. And look at NFPA 72. It will tell you what the detector spacings will be. But you also, when determining spacings, you must consider the air changes per hour. And that will tell you how to degrade the spacings. Typically, in a data center or anything that has a higher airflow, you'll typically start at 400 square foot spacings as a rule of thumb. Even though the detectors have about a 900 square foot spacing listing, typically with air changes and various other things, it will start at 400, go down to 250, and even in some subfloors, they'll go down to 125 square foot spacings. Now, when applying these detectors, the ionization detector is best to detect fast flaming fires, really fast flame rates. It picks up small particulate and that occurs from a faster propagating fire. But you do not want to use ion detectors in subfloors. Airflow, high airflow, typically anything over about, I think it's 3,000 CFM, can affect the ionization field that is in the ionization detectors. So you should never apply ionization detectors into a subfloor application. They put photoelectrics down in that area. The photoelectric detectors are good for cold smoke or smoldering fires. They pick up the larger particulate fire. Basically, it works off of an obstruction of light or deflection of light in the chamber. So that's why you see a lot of photoelectric detectors being used in duct detectors, subfloors, and even now with the adjustable sensitivity of the addressable systems, you can take a photoelectric detector and make it a little less sensitive. Where before, when you're stuck with conventional systems, typically in an open area arrangement, you would somewhat mix ions and photos together. But now, like I said, with the adjustable sensitivity of the detectors, you can, a lot of applications have just gone strictly photo and adjusted their sensitivities accordingly to the application itself. Then you have air sampling. Air sampling can detect smoke from a wide range of fire scenarios, from fast flame to smoldering to various other types. Now, just kind of comparing response time when looking at point detectors, heat, flame, smoke. You have air sampling that can detect and respond to a fire within, or at least get the first whiff within 30 seconds. Smoke detectors could take about 5 to 8 minutes. And then with sprinklers, you could talk anywhere, because it's a heat detector and you're really relying on thermal transfer and you need a lot of heat generation, you could talk about 30-minute lag time between when the fire starts to when it gets going to when it actually activates the thermal link. So you're talking about air sampling systems. They detect fire in the incipient stage, which is the lowest level of smoke out there. When we talk about incipient stage, it's kind of like starting up your heaters for the first time in the winter. Or when I was in the hotel, I started up the heater in there and you can kind of smell it, but you can't see it. That's really what air sampling is grabbing. Because when you're dealing with mission critical facilities, most of the time you're having conditioned air. Air changes are constantly being pulled in, pulled out, and also you have dilution. And a lot of times fires can be on a PCB board, it could be a capacitor, it could be a resistor, it could be a UPS, it could be something that starts off as a relatively low energy fire. Well, this is trying to give you, the air sampling system will give you the advanced warning so that you can go in 30 minutes, an hour, a couple days, depending upon what's burning. There's been some tests where you got the big 480 feeder lines into a data center. It may take a couple days for that big cable to heat up versus a 22 gauge wire, which can heat up and then automatically fuse and then burn up instantaneously. So, it just gives you, it's basically detecting off-gassing, plasticizers, various other stuff that's given off by overheating components in the electronics and various other things. So when you're talking about heat or smoke, when you're talking about your conventional smoke detector, you're really detecting smoke in the visible stage. I used to call it, you go away from college, you've been used to your mom's cooking and you're cooking for the first time and you've got your own apartment and you forget about the stuff that's in the oven and you open the thing up and you get the big plume of smoke and next thing you know your apartment's full of smoke and you can't see and you're opening the windows up. That's pretty much what smoke detectors are looking at. They're looking at about 3% per foot obscuration. So if I took a 10-foot room, it would actually be 30% obscuration of light. If I was to shine a light from this end to that end, I have 100% light here, but I'd only be able to see about 30% of that light at the far end of the room. Flame detectors are self-explanatory. They detect it in the flame stage, and heat detectors will detect it in the heat stage. So your photoelectric and ionization detectors have a sensitivity anywhere between 1.5 to 3% per foot. Detect smoke from a fire. It's really meant to evacuate your occupants and initiate your fire department response. Air sampling systems can be as sensitive as 0.00015% to 0.3%, or some 0.00046% to 7.62%. And the difference between air sampling and spot type detection is, spot type detection, you have a fixed point. At that point, it has to meet that criteria. Air sampling systems, they sample through a piping network. So you can have a fire that starts over here, but if it gets drawn up into the air handling system and then diluted throughout the area, you have a pickup point here, a pickup point here, a pickup point here. It's all bringing you back to one common point. So you may not have, on a spot type basis, you may not have enough to trip the spot type detector that might be sitting right here. But cumulatively, on an air sampling system, you'd be able to pull that air back, analyze it, and then find the particulates of combustion well before the spot type detector. Air sampling systems are about 1,000 times more sensitive than spot type detectors. Detects invisible products of combustion, outgassings of plasticizers, overheated PVC wire installation, overheated electrical components, and it's actually detecting it before there is a fire. Now, this is a report that was put out in 1993 about network reliability in the telecom industry. And they actually found that 90 to 95% of the damage caused in telco facilities, and this could definitely go for data centers too, is not caused by the actual fire, it's actually caused by the smoke. And things with fiber optics and various other things, those are more sensitive, especially when the transmitter and receivers. Smoke can definitely impair and corrode and various other things because you have caustic materials that are created as the fire burns. So with an early warning system like an air sampling system, you basically are alerting key personnel, shutting down equipment, removal of the fire source, prevention of smoke, contamination, protection of life safety, and continued operation of the assets. So when using these to go with clean agent type systems or gaseous fire protection, you really want to use both. One is not a substitute for another, okay? The air sampling system will give you the earliest warning, be able to go and detect it before it gets to a fire, basically turning it into a maintenance response, then a fire response. And then it's also preventing business interruption. So if I can get in there and I know 30 minutes prior to anything getting to a major event, it will give me a chance to take the board out, replace it, isolate my systems, and then be business as usual. Perfect example would be there was a fire at a reservations facility for a major airline, and they had air sampling systems in that facility as their first line of defense with a gaseous agent system as backup. Well, they basically, the air sampling system detected the fire well before it was an overheating resistor and a blown capacitor, and the PCB board solder track was starting to burn. So they alerted the personnel there. And basically, they were able to migrate all the data over to their backup servers, pull the board out, replace the board, migrate everything back, and the reservation people and various other people that were on the front lines talking to customers didn't know anything happened. However, if that was able to propagate and there wasn't any protection at all, there could have been some unwanted short-term downtime. But this way it was allowing them to prevent any kind of business interruption. Now, I know that there's a lot of specifications out there that people are writing saying that, well, I can use my air sampling system and use 2 contacts off the same detector to release my suppression agent. That is not a good practice. And the reason why is because you're still dealing with a single detector. And because you're dealing with a single detector, if that detector has a hiccup or a spike or something else, that maybe from a transient or something, you'll then have that system discharging $10, $20, $30, $50,000 worth of agent that a customer is going to have to recharge. So why we say use both is because you can get the earliest warning here, but then have it concurred by a spot type detector that there's actually an event. So, but it's 2 different technologies. Now, if you're going to use an air sampling detector and you're going to use 2 of them in the same room and cross-zone those, that would be okay, because you're getting 2 different independent detectors concurring that there's a fire. But you don't want to necessarily go off of a single detector when discharging suppression agents.
When you're talking about a single detector, in that case, you're talking about a single string of tubing into
Right.
1 sample.
Right.
Versus 2 sets of tubing into 2 samples.
Right. Or 1 set of tubing in a spot type detector. Sometimes when you put spot type detectors in the room, you can help somewhat cut down on installation costs by having, maybe your 1 detector covering this section, and then have a sampling pipe or a sampling point covering the next required spacing, and then alternate each point with sampling point spot type detector, sampling point spot type detector. That way you're meeting the zoning requirements, but you're also getting the concurring feature that the system is not just discharging off of a single detector.
So it's sensitivity do you drive the flow every time?
The sensitivity would be, well, it depends. If it's an addressable system, you could drop it on the fly in some systems, where if you get an air sampling system to go off, you get that input, you could actually change the sensitivity in the panel on all the detectors in that room. Otherwise, on other systems, it might be whatever the detector is preset at. If someone sets it at 1.5%, it's going to stay at 1.5%. Typically, for a photoelectric detector, it's probably on addressable systems, they may arrange it to be 2% per foot.
So the idea is that when your maintenance guy goes in there on an air alarm, that he can then basically increase the detection on the other unit so that it doesn't go off while he's working on it. Is that kind of the idea?
Yeah, you could do that.
And it's just a temporary thing, or we set it when we leave the...
Yeah, it would just be, well, I mean, it's kind of a feature that's more or less on the Fenwell side. But, like, I can tell you, speaking from our systems, that if we get an air sampling system going off, as long as that alarm's in, we can drop the sensitivities to a preset level of what we want it to be after getting that first alarm in. So you can make a quicker response.
Is that an automated function then?
Yes.
Okay.
So you can do that. And other systems may have the capability of doing that, but if they don't, then you're just going to be at whatever the installer sets the detectors to. They won't be able to necessarily adjust that. But it can be done. So with air sampling, you're getting the earliest warning. You're being able to take action sooner and stop the fire before combustion. But then you also want to cross over air sampling with spot type detectors for suppression release. And then as far as system solutions go, you want to look at, from a mission critical facility, you want to look at detection. Really what you want to do is you want to look at smoke. You don't want to necessarily have heat detectors in mission critical facilities unless you're protecting a generator room. That's really where heat detectors are for backup generators. But as far as smoke detectors go, that's where they're more universally used in those type of areas. The bad thing about using heat detectors in mission critical areas is that you have thermal lag, you don't get the quick response, and usually by the time you get a heat detector to go off, it's going to, something's going to be fully involved. Then as far as controls go, you get your fire alarm, suppression release panel, and then as far as suppression goes, you have your clean agent systems. So really in conclusion, you want to understand and assess the risk. We want to look at the total cost of ownership because, some of these mission critical facilities aren't necessarily an office space or a conference room or necessarily a big assembly area like this. It's more or less, again, the areas that are going to be pertinent to the survival of a business, whether it's from a records perspective or if it's from a IT perspective. I mean, a lot of times county halls here have all your deeds, have all your records of ownership. If some of those aren't backed up somewhere, if there was a fire there, you couldn't prove that you actually own your house. So, that's really what it comes down to. Talk about, seek subject matter experts. I know there's various fire protection companies in here. From my perspective, we work with Electric Scientific. They've been in business since, for about 30 plus years doing fire protection, maybe a little bit more. But basically the people that are dealing with the suppression agents and mission critical facilities on a regular basis are going to be the people that are going to be able to tell you how they did certain applications, what they did, how they applied their products to meet the requirement of an end user. So again, you got mission critical facility protection, scope, facility control, and fire suppression. And then I'll leave you with one thing. The bitter taste of poor quality lingers long after the sweet taste of low bid. You want to make sure you're getting apples to apples. You want to make sure that someone's not cutting corners and giving you what you think you should be getting and find out after that you're not getting it. Any questions?
Well, I think all the questions have been asked. No? You're going to ask a question right there. No, he knows everything. Subject matter expert. Well, thank you very much for coming out. It was, again, there's always a lot of things to learn and to review. Even if you've been in that business, there's always something else that comes up. Thank you very much for coming down.
For those that are interested, I did bring some handouts. In the handouts, it's got all the different product information on panels that we offer. There's also a specification discs. There's a build-your-own spec builder. And there's also an agent calculator in there.